Good morning, mathematicians. Today we are going to be solving rational equations. You're actually going to be looking at it today and tomorrow as well. So we were doing something similar with rational equations back in 605, the best classroom in the building. We were multiplying them, dividing them, adding them, subtracting them, and all of that. So we're going to do a little refresher and then build on it because we're actually going to have equations involved. So let's start with our do now. I'm telling you guys to use the technique of cross multiplication to solve each of those equations. I know that it's an equation simply because there's an equal sign there, and I know that they are rational equations because I have fractions. Remember, that's all that rational means. So when I'm saying cross multiply, I already have it set up for us. We're able to do that because I have one fraction that is equal to the other. So that allows you guys to go ahead and draw your cross multiplication. So I'm just going to rewrite that as 2 times x minus 1. And then I'm also cross multiplying over here to keep it balanced. So I'm going to have 5 times 4x plus 5. That's all that cross multiplication here does. But a lot of times we already understand this and we just start by distributing and writing 2x minus 2 equals, and same thing over here, distribute 20x plus 25. So if you went ahead and cross multiplied and got down here, that's the same exact thing. I'm just showing you guys the extra step there. And now let's pretend I just gave you this. Back in Algebra 1, I said, hey, let's solve for x. Again, you have the freedom to move whatever you want over. So I am going to start by subtracting 20x over here to combine it with its like term on this side. So I'm going to have negative 18x minus 2 equals 25. And now I'm going to be adding 2 to both sides. And I'm going to have negative 18x equals 27. And your last step here is to divide by negative 18. X equals, I have negative, and I already know that I can reduce that. And if you're not sure what it's equal to, go ahead and open your graphing calculator app or grab your calculator. 27 divided by negative 18. Negative 1.5, or we know, because we're dealing with rational expressions here, math, enter, makes that negative 3 over 2. So I'm going to write it as 3 over 2. And that's your final answer there. So to recap here, we started with 2 rational expressions, one fraction equal to another fraction. Since that's the case, we were able to cross multiply. And that completely destroyed my fraction there. And then it was like you were back in Algebra 1, and I just said, hey, solve for x. You guys can go ahead and solve b on your own. You should get x equals 5 and x equals 2 when you finish that. So do that to check. But again, you're just cross multiplying there, and then you're going to solve for x. I'll give you a hint. When you do cross multiply, you're going to get a quadratic function, which is super cool. And the only way to solve that is by factoring. So enjoy that. You can pause the video, try it on your own, and you should get x equals 5 and x equals negative 2. And you can refer to this if you need to. But yeah, good old ABC method. But continuing on with what I really want to focus in on is the old technique that we became like very comfortable with. And that was finding the least common denominator. We found the least common denominator when we were adding and subtracting rational expressions back in, I don't know, February. So I want to do the same technique here. I'm giving you the same exact problem as the do now, but I want us to now determine what is the least common denominator. And then I'm going to multiply both terms by that least common denominator. So I just simply rewrote the same exact problem over here. Remember when I'm looking for the LCD, I'm looking at all of my rational expressions, all of their denominators, and I'm thinking, okay, what is the smallest number that they have in common? And remember, if you're not sure, you can take those values that are in the denominator and start listing the multiples of them. So like 2, 4, 6, 8, 10, 5, 10. Okay, bingo, that's the smallest number here that I see in common, which means that my least common denominator for this case is going to be 10. I no longer want to cross multiply, and the whole reason why I'm showing you this is because if I don't have an equal sign in between fractions, I won't be able to cross multiply. You already know that's coming your way. So I'm going to show you this technique here. I'm going to take my least common denominator and multiply both of my rational expressions by it. And remember, when I taught you guys this in February, we took whatever that least common denominator was and I distributed it to the terms in your numerator. So I'm going to do 10 times 4x, and that's going to give me a 40x. Then I'm going to do 10 times 5, and that's going to give me a plus 50. And that denominator is just coming right down, still divided by 2. Here, I'm doing 10 times x, which is going to leave me with a 10x. And then I'm doing 2 times negative 1, which is going to give me a negative 10. And same thing, I'm dividing that by 5. This was when the nice, beautiful magic happened, because if I looked at this separately and I said to you, okay, what is 40x divided by 2? You're going to tell me that that's 20x. And if not, then you made a silly mistake. And then I'm going to look at 50 and I divide that by 2. Oh, that's going to give me 25. Okay. Bam. Just like that, your fraction is completely gone. Same thing over here. 10x divided by 5. I'm going to be left with 2x. I have negative 10 divided by 5. I'm going to be left with not a negative 5. Oh my god, that would have destroyed me. A negative 2. I miss you guys in class. Now look, I have 20x plus 25 equals 2x minus 2. Well, if you compare that to what we did on our do now over there, 2x minus 2, 2x minus 2. 20x plus 25, 20x plus 25. So you're literally at the same exact step, and I know that when I solve this, like when I bring this 25 over, and then when I subtract this 2x, all of that, my final answer is going to give me 3 over 2, because I have the same exact equation that I had there. Super cool, people. You can't make this stuff up. So I already know what my final answer there is going to give me. And you guys can fill that in here. This method is always going to work. So when we look at our next example here, like why would we multiply all terms by the LCD instead of cross multiplying? That's what I'm basically asking you here. Like, can we cross multiply on this equation? Why or why not? So I'm going to give you a minute to think about that, why I erased my whiteboard, because I will show you one more example. Make sure you are explaining why. So I have 1/2 minus 9 over 4x equals 3 over 4x. Okay, so I first asked you, can we cross multiply? Well, if I wanted to cross multiply here, I would like cross multiply this and this, but then I would still have like this 1/2 here. And I can't cross multiply that and that because they're not equal to each other. Those are being subtracted. So you definitely cannot cross multiply here. So in order to solve this, we're going to have to do that method that we just did over here. Like find that least common denominator. That should always be your first step when you're adding and subtracting rational expressions. So again, I'm just focusing in on each of my denominators here. I see a 2, I see a 4x, I see another 4x, okay. Remember, you cannot change what's in the denominator. Like, if there's an x here, it cannot just magically disappear. That just means now all of your denominators need to have an x. So looking at those 3 values there, I know that my least common denominator here needs to be 4x. Which is super nice because in this case, actually nothing here will have to change. So once we found our least common denominator on this example, remember we took that value and we multiplied it to all of your rational expressions into the numerator. So I'm going to take 4x and I'm going to multiply it by this fraction. I'm going to multiply it by this fraction and by that fraction there. So 4x times 1, well, that's going to leave me with a 4x divided by 2. I had that subtraction sign. 4x times 9 is going to give me a 36x divided by 4x. And then 3 times 4x will leave me with a 12x divided by 4x. Notice denominators just got brought down and your numerators changed because we distributed the LCD to each of them. Now again, if I said to you, hey, 4x divided by 2, what is that? You'd be like, oh my god, miss, that's so easy, it's 2x. Bring down my subtraction sign. 36x divided by 4x, those x's are going to cancel out, and I'm definitely going to be left with a 9 equals 12x divided by 4x. Again, you're just going to be left with 3. And just like that, that whole scary equation disappeared, and you're left with 2x minus 9 equals 3. And hey, we're just going to solve for x here. So I'm definitely going to perform the inverse operation, add 9 to both sides. I'm going to have 2x is equal to 12. And my last step there, divide by 2, which is going to give me x is equal to 6. And that's it. That is your final answer. You could go ahead and even be super great if this is New York State Regents and you finished your test early. I could plug 6 back into my original here, anywhere that I see an x, and show okay, when I do 1/2 minus 9 divided by 24, when you multiply those, that's going to give me the same thing as when I do 3 divided by 24. Super cool. All right, you have a Plickers, you have a few exercises here to practice, 5 questions total. Enjoy, rock and roll. Email me if you have questions. Make sure you submit it to me. Have fun.